Now that we've defined all the different types of compounds and how we form ionic compounds and all this sorts of great stuff, we want to end by talking about how we name compounds. So when we talk about naming compounds, we know that formulas are really where it's at in terms of describing what atoms are in a molecule or in a compound, molecules for covalent. That really is kind of the recipe and the be-all end-all like chemical description. But we also have names, like words that we use to talk about chemicals, and these are going to be much more used conversationally. And so we want to learn what these are because we'd see them a lot of times on like labels for chemicals, like on the actual packaging when we're just talking about things. Sometimes we do just read off the formula, but we also want to have kind of a language-based description for the name of our chemicals. And I should note that we're going to talk about what are called the systematic names. Systematic, that word means there's a system to it. So we're going to be talking about chemical names that have rules that are based around describing what's in the compound. A lot of chemicals have just historical names like water. There's no implications to what's actually in water, just that it's water. And there's a lot of those kind of common names for chemicals, and we'll learn a couple of those that we'll need to know, but for the most part, we're going to focus on these systematic names where there's a system for how you go about naming things. And the idea is that the name should convey what's in the compound. And so, like we have these divisions so far, the first rule in naming a compound is going to be determining whether or not it's ionic or covalent. And so when we're looking at formulas, the thing we want to be able to figure out is this compound ionic or covalent? With systematic names, there is a system to name, and this is it. So one of the things, we're going to work through this bit by bit, but you can see there's overall a process where it's based around questions and kind of a process to name things. And so we're going to work through a lot of examples to get some practice with how things are named. But just want to show this up. We'll walk through it. Don't need to figure it all out right now. But this is the system, and this is the idea that we can always follow this. I do want to note there's a system that also is for naming acids. The book talks about naming acids. We're just not going to cover that. All right, so ionic versus covalent is the first question we want to answer. And how we're going to answer this is we're going to rely on the fact that ionic compounds have to be neutral, right? That was a big part of when we were talking about ionic compounds. We know that they have to have an anion and a cation. Okay, so we need both of those. And so if we want to think about where we find anions and cations, if we look at the periodic table, we really want to focus on cations. And that is because when we look at, we know that cations are only formed by metals. Non-metals don't form cations when they're single atoms. They always form anions. They're also the types of atoms that form covalent bonds. So ionic compounds have to contain an anion and a cation. The only types of atoms that form cations are metal. So, and the cation has to be first in the formula. So when we see a formula, if the first thing is a metal, that would mean that we are dealing with an ionic compound. There is one complication, and that comes in NH4+. Ammonium is a polyatomic cation. So if our molecular formula starts with a metal, it's going to be an ion. If our molecular formula starts with nitrogen, we would think, hey, that's a nonmetal. But if it's NH4 all together to start our compound, that makes it an ionic compound. So NO2, NH3, NF3, NS2, all of those are going to be covalent compounds. When it's NH4F, that would be an ionic compound, right? The N is always going to be covalent, except when it's NH4, because that's ammonium, which is a cation. It's not a metal, but it's a polyatomic. In terms of metals are the only atoms that form cations, but you can have these polyatomic cations. All right, So let's look at some examples of classifying these compounds as ionic or covalent. So NaCl, H2S, SiCl4, and SnCl4. When we're looking at determining whether or not a compound is ionic or covalent, we really want to start with what is the first atom in the compound and where is it on the periodic table. So NaCl, for example, Na, sodium, is right here. Right? We can see it's in the far left, it's in that first column. That is a metal. Because sodium is a metal, we know this is an ionic compound. Okay? Because metals form cations, the chlorine is a nonmetal, that's going to form an anion, this thing is an ionic compound. H2S, if we find H on the periodic table, that is on the side with the metals, right? But we want to be careful. We can see in this periodic table, it's lifted up off of that first column, and that's because it's actually a non-metal. So because that's a non-metal, sulfur S is also a non-metal. These are all non-metals together. There are no cations in there. So this is a covalent compound. SiCl4, I got Si right here. You can see it's close. You know, that green color in this case is for the metalloids that we talked about. But importantly, we can see that red, that black line. Sulfur is above that and to the right, meaning it's a non-metal. So that is a covalent compound. SnCl4, we can see Sn isn't very far away from silicon, but importantly, it's on the other side of that metal non-metal line. Sn, tin, is a metal, so this is an ionic compound. Whenever we're dealing with this case of ionic versus covalent, we're really just looking for what is that first atom. If it's a metal, then it's an ionic compound. If it's non-metal, it's covalent. And the only exception is NH4, that ammonium cation, which we do still want to be on the lookout for. But otherwise, we just be focusing on metals.
Participation 6.5, question 3. Classify the following compounds as ionic or covalent. A, NH4Br, B, ZrO2, C, FeF3, and D, PCl3. This is the third question on participation 6.5, due Friday, June 5th at 11:59 p.m. over on Blackboard. Link to the assignment is right below links to these videos. Again, classify the following compounds as ionic or covalent: NH4Br, ZrO2, FeF3, and PCl3. And there's a periodic table there that you'll find useful. There's also one in the additional resources folder at the bottom of the module page. Okay, another participation question for 6.5. Getting more and more questions as we make our way through the set of videos. Got a couple more to go. See you in the next one.